Hello learners, today we are going to talk about another fun topic in physics. Let's begin. Have you ever wondered why things fall towards the earth? All things fall towards the earth due to an attractive force. When two non-zero masses are separated by a distance, then there will be an attraction between those two objects. This force is known as gravitational force. Let's look at some examples for gravitational force. An object that you throw up in the air, that object accelerates or falls towards the earth. In physics, the object experiences a downward force known as gravitational force. We saw that the gravitational force is the attractive force between any two non-zero masses separated by a distance. Based on what we learn about the gravitational force, both apply an equal force to attract the other object towards itself. So, if the forces are equal, which one will accelerate more? So, does the earth move towards the object or object moves towards the earth? Based on the Newton's second law, we know that the force applied is the product of mass and acceleration. So, the acceleration will equal force over mass. The acceleration is inversely proportional to the mass. If the mass of the earth is me and the mass of the object is mo, you know the mass of the earth is much more better than the earth. And also, if the mass increases, then the acceleration decreases. Due to this reason, the object starts to accelerate towards the earth and not the other way around. Hope that makes it clear. Now the question is, how do we quantify this force? To understand this, we need to understand a simple concept called universal law of gravitation. If there are two objects, A and B, separated by a distance d, the distance between the centers is considered the distance between two objects and not this distance. Assume that the mass of the object A is capital M and the mass of the object B is simple m. As object A is bigger, let's assume capital A is bigger than capital simple M. The universal law of gravitation says that every object in the universe attracts every other object with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Let me repeat. The force is directly proportional to the product of their masses and it is inversely proportional to the square of the distance between them. With this data, we can write it mathematically like this. If the distance between the two objects increases, the lesser will be the gravitational force. And if the mass of an object increases, the gravitational force will also have more magnitude. That means the force is directly proportional to the product of masses and inversely proportional to the square of the distance between them. This can be written as F equals G times capital M into simple m over d squared. Here, G is the constant of proportionality and it is known as universal gravitational constant. The equation can be modified and written as G equals F times D is part over capital M into simple n. The value of G was found out by Lord Henry Cavendish using a torsion balance. The universally accepted value of G is as bound. This is the summary of today's lesson. Thank you very much for listening and may God bless you. Let's meet on another day with a fun topic in physics. See you all.